And this is my Physics 2211 Lab 1 experiment. We will go into an introduction and then use tracker analysis of a marker rolling at constant velocity and compare that to a computational model, and then move into the results and discussion. The purpose of the lab is to record and measure the motion of a rolling marker at constant velocity without changing direction using tracker, and compare the motion to a computational model using GlowScript. We can predict that the computational and predicted model should look similar because the computational model uses equations to predict the motion based on observed values. We can ignore air resistance and friction forces for this experiment. The fundamental principles used in this lab were Newton's first law and Newton's second law. Newton's first law states that an object will remain at rest unless acted upon by an external force. Newton's second law states that an object maintains a constant speed and direction, resulting in zero acceleration and therefore a net force of zero. We can use the velocity and position update formulas for this experiment. Here's the model where the system is the marker and the surroundings are everything else. As a force was applied to get the marker rolling, and once it was moving, it would maintain the same speed and velocity due to the normal force and force of gravity canceling out, therefore resulting in a velocity of zero. Here's a screenshot of my tracker analysis of constant velocity, where we can use the slope of the graph to calculate the initial velocity, or delta r over delta t. Here are the initial conditions of the computational model, where the initial position and velocity from tracker was put into GlowScript to match that of the recording, and the size of each time step was delta t. The velocity and position update formulas mentioned earlier were used to calculate the position and velocity of the computational model, which would then be compared to our model. Here are the GlowScript results. As time moves on, the position is moving in a positive direction, therefore moving in a positive velocity. Here are comparative results. As time progresses, the two lines start to deviate slightly. The tracker's lines start to decrease, indicating a decrease in speed and velocity, and this could be due to underlying factors. Possible errors in this experiment could be outside forces like friction and air resistance that we did not account for, and the position tracking, which meaning placing the center of mass on tracker. What if the axes were interchanged? The slope of the graph would be negative, but this would not change the results or the comparison. For this experiment, is the net force zero? The computational and predicted models do not align, so therefore there are other forces at play, and therefore the net force is not zero. Thank you.